let's start with a warm-up problem to avoid getting any mental cramps as we learn new things. So this is a problem that hopefully if you understood what we did in the last video, you can kind of understand what we're about to do right now. And I'm going to escalate it even more. In the last video, we finished with I think we finished with a 4-digit number times a 1-digit number. Let's up the stakes to a 5-digit number. So let's do 6,400. Let's do 64,329 times, let me think of a nice number, times 4. Times 4. I'm going to show you right now that we're going to do the exact same process that we did in the last video. We just have to do it a little bit longer than we did before. So we just start off saying, okay, what's 4 times 9? 4 times 9 is equal to 36. Right? 18 times 2, yep, 36. So we write the 6 down here. Carry the 3 up there. Just put the 3 up there. Then you got 4 times 2. 4 times 2. 4 times 2. And then you're going to have to add the 3. So let me just write that there. Plus 3 is equal to, you do the multiplication first. So you can even think of it as an order of operations. But you just should know that you do the multiplication first. So it's 8 plus, so 4 times 2 is 8, plus 3 is equal to 11. Put this one down here and put the 110 and 11 up there. Then you got 4 times 3. 4 times 3. 4 times 3. You got that one up there, so you're going to have to add that plus 1 is equal to, that's going to equal 12 plus 1, which is equal to 13. So it's 13. Then you have 4 times 4. 4 times 4. You have this little 1 hanging out here from the previous multiplication, so you're going to have to add that. And that's equal to 16 plus 1. It's equal to 17. Stick the 7 down here. Put the 1 up there. We're almost done. Almost done. And then we have 4 times 6. 4 times 6 plus 1. Plus 1. What is that? 4 times 6 is 24, plus 1 is 25. Put the 5 down here. There's nowhere to put the 2. There's no more multiplications to do, so we just put the 2 down there. So 64,329 times 4 is 257,316. And in case you're wondering, these commas don't mean much. They just help me read the number. So I put it after every 3 digits, so I know that, for example, that everything after this, these are in the thousands. So this is 7,000. If I had another comma here, then I know this is millions. So it just helps me read the problem a bit. So if you got that, you're now ready to escalate to a slightly more complicated situation. Although the first way that we're going to do it, it's actually not going to look any more complicated. It's just going to involve one more step. So everything we've done so far are a bunch of digits times a 1-digit number. Now let's do a bunch of digits times a 2-digit number. So let's say we want to multiply. Let's say we want to multiply 36 times, instead of putting a 1-digit number here, I'm going to put a 2-digit number. So times 23. Aha. So you start off doing this problem exactly the way you would have done it if there was just a 3 down here. You can kind of ignore the 2 for a little bit. So 3 times 6 is equal to 18. So you just put the 8 here, put the 10 there, or the 1 there, because it's 10 plus 8. 3 times 3 is 9. 3 times 3 is 9 plus 1. So 3 times 3 plus 1 is equal to, that's 9 plus 1 is equal to 10. So you put the 10 there. There's nothing left. You put the 0 there. There's nothing left to put the 1. So you put the 10 there. So you essentially have solved the problem that 36, let me do this in another color, that 36 times 3 is equal to 108. That's what we've solved so far. But we have this 20 sitting out here. Right? We have this 20. We have to figure out what 20 times 360 is. Or sorry, what 20 times 36 is. So what you do to multiply, this 2 is really a 20. And to make it all work out like that, what we do is we throw a 0 down here. We throw a 0 right there. And in a second, I'm going to explain why exactly we did that. So let's just do the same process as we did before with the 3. Now we do it with the 2, but we start filling up here and move to the left. So 2 times 6, 2 times 6, that's easy. That's 12. So 2 times 6 is 12. We put the 1 up here, and we have to be very careful because we had this 1 from our previous problem, which doesn't apply anymore. So we could erase it, or that 1 we could get rid of. If you have an eraser, you get rid of it, or you can just keep track in your head that the 1 you're about to write is a different one. So what were we doing? We wrote 2 times 6 is 12. Put the 2 here. Put the 1 up here. And I got rid of the previous one because that would have just messed me up. Now I have 2 times 3. 2 times 3 is equal to 6. But then I have this plus 1 up here, so I have to add plus 1. So I get 7. So that is equal to 7. 2 times 3 plus 1 is equal to 7. So this 720 we just solved, that's literally, let me write that down. What is that? That is 36 times 20. 36 times 20 is equal to 720. And hopefully that should explain why we had to throw this 0 here. If we didn't throw that 0 here, we would have just a 2. We would just have a 72 here instead of a 720. And 72 is 36 times 2. But this isn't a 2. This is a 2 in the tens place. This is a 20. So we have to multiply 36 times 20, and that's why we got 720 there. So 36 times 23, let's write it this way. Let me write it. Let me get some space up here. So we could write 30. Well, actually, let me just finish the problem, and then I'll explain to you why it worked. So now to finish it up, we just add 108 to 720. So 8 plus 0 is 8. 0 plus 2 is 2. 1 plus 7 is 8. So 36 times 23 is 828. Now you're saying, Sal, why did that work? Why were we able to figure out separately 36 times 3 is equal to 108, and then 36 times 20 is equal to 720, and then add them up like that? Because we could have rewritten the problem like this. We could have rewritten the problem as 36. Let me write. The original problem was this. We could have rewritten this as 36 times 20 plus 3. And this, and I don't know if you've learned the distributive property yet, but this is just the distributive property. This is just the same thing as 36 times 20 plus 36 times 3. If that confuses you, then you don't have to worry about it. But if it doesn't, then this is good. It's actually teaching you something. 36 times 20 we saw was 720. We learned that 36 times 3 was 108. And when you added them together, we got what? 828? Is that what we got? We got 828. And you could expand it even more like we did in the previous video. You could write this out as 30 plus 6 times 20 plus 3. Actually, let me just do it that way, because I think that could help you out a little bit. If it confuses you, ignore it. If it doesn't, that's good. So we could do it 3 times 6. 3 times 6 is 18. 18 is just 10 plus 8. So it's 8. And we put a 10 up here. And ignore all this up here. 3 times 30. 3 times 30 is 90. 90 plus 10 is 100. So 100 is 0 tens plus 100. I don't know if this confuses you or not. If it does, ignore it. If it doesn't, well, I don't want to complicate the issue. And now we can multiply 20. We can ignore this thing that we had before. We're ready. 20 times 6 is 120. So that's 20 plus 100 plus 100. So I'll put that 100 up here. 20 times 30, you might not know, is 2 times 3, and you have 2 zeros there. And I think I'm maybe jumping the gun a little bit, assuming a little bit too much of what you may or may not know. But 20 times 30 is going to be 600, and you add another 100 there, that's 700. And then you add them all up, you get 800, right? 100 plus 700 plus 20 plus 8, which is equal to 828. My point here is to show you why that system we did worked, why we added a 0 here to begin with. But if it confuses you, don't worry about that right now. Learn how to do it, and then maybe re-watch this video. Let's just do a bunch of more examples, because I think the examples are what really, hopefully, explain the situation. So let's do 77. Let's do a fun one. 77 times 77. 7 times 7 is 49. Put the 1 up here. The 1 up there. 7 times 7, well, that's 49. Plus 4 is 53. 53. There's nowhere to put the 5, so we put it down here. 7 times 7 is 49 plus 4 is 53. Stick a 0 here. Now we're going to do this 7. So stick a 0 here. 7 times, and let's get rid of this right there because that'll just mess us up. 7 times 7 is 49. Stick a 9 there. Put a 4 there. 7 times 7 is 49 plus 4, which is 53. 53. So notice, when we multiplied 7 times 77, we got 539. When we multiplied 70 times 77, we got 5,390. It makes sense. They just differ by a 0, by a factor of 10. And now we can just add them up. And what do we get? 9 plus 0 is 9. 3 plus 9 is 12. Carry the 1. 1 plus 5 is 6. 6 plus 3 is 9. 9. And then we have this 5. So it's 5,929.